algorithms, for example, that we don't even think when we do, are much more difficult for AI to execute. For example, making a cup of tea in a kitchen that you've never seen before. You know that you should just go find the cupboard, open the cupboard, find the mug, put the tea bag, and pour hot water. For an AI, it's extremely difficult to actually have that cognitive process or exhibit that sort of cognitive behavior. However, more recently, we started reusing a lot of the AI systems or models that have been created quite long ago, since the days of Alan Turing and Marvin Minsky. They've had what they call biologically inspired AI models. And these biologically inspired AI models, they try to use some biological type of processes, such as in the case of artificial neural networks, trying to simulate the thought process in the human mind. As you know, in the human mind, we have billions of neurons that are interconnected with each other. And each time we learn something new, or we see something new, or we actually experience something new, interactions or little signals between these neurons in our brains signal to each other that this is something new, and the more it sees from it, the more it learns. And that's what learning behavior is. In artificial intelligence, we have the very typical, it's quite old model called artificial neural networks, which mimics this behavior. We just create pieces of code which are nothing but mathematical functions. We actually layer them into various layers. In each layer, we have a function that is a learning function. And between these layers, we start off by having interactions or different links between these various layers that are nothing but random numbers. However, the learning process starts by starting with giving it an input, and we already know what is our desired output, so we're training the system. When we give an input and the system outputs the first output, there will be always a difference between the desired output and the actual output. That difference is called an error rate. We simply take that error rate and feed it back to the network. It's called a backpropagation process. And in backpropagation, all these different interactions that started off as random numbers, they will get updated. And once they get updated, we feed another set of training data to the system. We'll get an actual output. This time, the error rate will be smaller than before because the system has been trained and then the interactions have been updated. And we repeat that process on various iterations or epochs until the error rate is minimal. So if we're trying to do image recognition, we will feed it the image of a car, and then it will recognize, or would have learned that this is a car. If we're feeding it financial data, and we're trying to predict a head and shoulders, then it will know that this is a head and shoulders, and the next move should be a by position, and so on and so forth. So it's trying to use that form of mechanism to learn. Another mechanism that we look at, and I'll go through it very briefly, is genetic algorithms. Even though the name is quite fancy, it's a very simple process that tries to mimic the Darwinian process of evolution by creating random solutions. So let's say we have a problem that does not have a known mathematical solution. We start off simply by generating 100 random solutions. And we say that this is a population of solutions. We split these 100 numbers into two types of solutions, the mothers and the fathers. Remember that these solutions are nothing but binary numbers, so ones and zeros. So a sequence of ones is a father, and a sequence of ones and zeros is a mother. We marry them together, and we will have an offspring which is half of the mother and half of the father. And then we go through a process which what we call natural selection, meaning that we compare the offspring to the moms and to the dads. And if the offspring is a better solution or is giving us a better result, then natural selection takes its course and the offspring replaces the parents. We repeat that process many times, and the more we repeat it, we are creating generations. And after 1,000 generations, for example, we will have a solution that is very close to the desired mathematical solution that we did not have in the first place. And it all started by generating a list of random solutions, and so on and so forth. We also introduce a small probability of mutation just to shake the system a little bit. So with a probability of 0.01%, we mutate the offspring to check if we have a solution that might be somewhere else on the curve, that might be closer to the actually desired mathematical solution, and so on and so forth. I mean, just to go back here, these are not the only AI systems that we use. I mean, for example, we use fuzzy logic. Fuzzy logic is quite simple. As you know, in Boolean logic or normal logic, everything is either true or false, 1 or 0. However, that's not how human common sense works. When we say, is this true or is this not true, we always say, I'm not sure, it's not 100% true or not. We always look at the gray area in the middle, and this is what fuzzy logic tries to do. Fuzzy logic does not give you a definite answer of a 1 or a 0, but every answer has a degree of membership or a degree of truth. If you think about it, us humans, we experience our decision-making process from a fuzzy perspective. Let's say you're driving your car at a certain speed, and suddenly the car in front of you stops. It's not Boolean, it's not 0 or 1, it's not brake or no brake. You quickly calculate the distance between you and the car in front of you, the brake with a certain degree of membership, whether it's 40%, 50%, 100% if we're too close, and so on and so forth. Fuzzy logic mimics that exact method. One more thing, and maybe it's the last AI model that I'm going to explain, is reinforcement learning. Reinforcement learning is a process whereby we teach the system through experience by creating two mathematical functions. One is called a reward function, and one is called a punishment function. And each time the system takes the right decision, we trigger a reward function. The system is happy. It knows that this is the type of output it needs to output. And if it does something wrong, we trigger a punishment function, and it knows it's taken the wrong decision, and it should not do this again. In a way, this is very similar to the way we learn how to ride a bike. When we are riding a bike or learning how to ride a bike for the first time, if we do the wrong move, we fall, it hurts, it triggers a subconscious punishment function in the brain. We know that we should never, ever do that move again. If we are riding the bike and we're going in a straight line and we are getting a subconscious reward, like I am actually riding the bike and this feels really nice, we know that this is the type of behavior that I need to exhibit to ride the bike well. Which is why riding a bike, unlike many other skills we learn throughout our life, is something that we never forget, no matter how long we haven't rode a bike for. This moves me to another area, which is data, or big data in general. And in the spirit of storytelling, I am actually going to tell you my story of how I actually got into data science and data analytics. And it was through my first job. My first job, believe it or not, was with my dad. My dad, who's featured quite a lot in today's talk, God bless him. He realized that one fine summer when I was going to university, and by the way, I got to university at quite an early age. I was 16 and a half, 17 years old. And he came to me and said, get off your chair. Don't stay in the basement. You're coding on your laptop all the time. Go and get a job. So I, said, okay, what should I do? He said, I'll give you a job. And my dad had an import-export business. It was quite international. He had customers, clients, suppliers from different countries around the world. So he had some complex databases of cash flows, goods coming in, goods coming out, and money coming in, consolidations, supplies, various things that were scattered around various sheets and various, let's call them data sets. And he told me, your job is to clean this mess here, create some sheets, project the cash flow. I want you to add this to this and give me a result in, there. And these data sets were quite big. Being a coder and a geek, I decided to cheat a little bit because my dad thought it will take quite a long time to clear the mess. I decided to write some code to actually do the job for me because I'm also quite lazy and I'd rather be doing other things than work. So I decided to run some scripts to actually do the job for me. It took me an hour to just create a script that will actually do exactly what he wanted to do. Took me maybe 5 seconds to run the script and actually execute the code and achieve the result that he wanted. I never told him that I did it quite fast. He thought that I was working all along. When he found out what I did, he bought me a new laptop and he fired me. So that was my experience with my first job.